thank D2L. Sorry. First of all, I want to thank D2L for letting us use their corporate Zoom account once again. We've been lucky that they have been letting us do so since 2020. So, want to give a big shout out there. And then your KWSQA board, once again, for organizing. So we do want to start off with a land acknowledgement. So the KWSQA head office is located on the Haldeman Tract, which was land that was promised to the Haudenosaunee people of the Six Nations of the Grand River, and is within the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. We are very privileged to be able to live, work, and build our software quality community in such a great region. As always, our KWSQA Code of Conduct is in effect for all of our virtual and in-person events. If you want to find out more about it, the entire Code of Conduct is located on our website. And if you ever have an issue or you want to report an incident or anything like that, please reach out to us at info@kwsqa.com. A quick reminder, if there's anything that you want to learn more about in regards to KWSQA, please go to kwsqa.org. There's information there on our quality talks, our testing games, both upcoming ones or the proposals are there if you want to submit an idea for a quality talk or a testing game. There's more information about our mentorship program. There's also now our Targeting Quality 2024 section is populated with all of the up-to-date information. You can also purchase your memberships or sign up for our mailing lists there. Which brings us to Targeting Quality 2024. So it is confirmed we will be back at the Cambridge Hotel and Conference Center September 30th and October 1st this year. Our call for proposals is still open. It'll be open until April 16th. And right now, the super early bird tickets are on sale until April 28th. So these are the cheapest tickets that you will be able to get for Targeting Quality this year, kind of getting the benefit of taking the chance before the actual speaker and program list is announced. But we can confirm it should be a very good lineup this year. As always, sponsorship packages are also available at any time, and all of this information can be found at targetingquality.ca or at kwsqa.org and going into the TQ 2024 section. Upcoming quality talks. So with our alternation between virtual and in-person, next month we are going to be in person back at D2L, and we're actually going to be facilitating a lean coffee discussion. So lean coffee is kind of a semi-facilitated discussion around a variety of testing topics that you can kind of choose to engage in and chat with some of the other community members that we have. So stay tuned for more info on that. You should see an email coming out in the next week or so. Also, as always, there is a survey that will come out at the end of this meeting. It'll come out later this afternoon, asking you to give feedback. So this feedback is really important both to the KWSQA board to make sure that we're running talks that are actually benefiting our community. And it's also important for our speakers. So we want to make sure that we can share feedback with them after their presentations as well. And every kind of meeting that you give us feedback for, you are entered in for a chance to win a $50 Amazon gift card that we will draw for at our AGM in December. Now, without further ado, I will hand things over to Matt Heusser for an hour. I guess it's 45 minutes of lean software delivery now, since this is a bit of a shortened time frame. Matt, if you want to take it away.
Sure, thank you. Here we are. Am I pressing? Is it sharing?
Perfect.
Yep. And this is an hour of lean software testing in 45 minutes. So it's based on a 3-day course that we get to an 8-hour tutorial given at KWSQA Targeting Quality Conference before. So I'm going to really hit the high note. So hopefully what this should do is be like the most powerful stuff that is easiest to understand, that is easiest to implement, right? And so to do that, I want to talk a little bit about where this idea of lean came from. Does it apply to software? How do we apply it? How can we measure improvement? And then a little bit of actual grounding in software testing, instead of sort of high-level ideas about workflows, which, excuse my background music. there's going to be a fair amount of high-level conversations about workflows, and we've kind of have to reach a large audience that I've never met before. We've done no surveys. I don't know much about you. There's some sort of distribution, and what are the most valuable things for for most people? I think if we can do that, we'll be successful. That's my goal. You can figure out if I did it later, I suppose. You can ask questions the whole time, and put them in chat, and we'll collect them, and I can answer them later. Because I'm sharing my screen, I can't see your chat messages, so please don't make fun of me too much. So let's start with where the concept of lean comes from. Many people may be familiar with the lean startup. That's not really what I'm talking about, although there's a great deal of overlap and some inspiration. The lean startup being figure out the demand for a product and then build it. But it is also about a very efficient, effective way to get the work done. So in particular, I'm talking about the Toyota and Japanese auto revolution of the 20th century. And the gentleman in this picture is Taiichi Ono, who was the chief engineer at Toyota. And in the United States, where I am, probably Canada too, when we say engineer, we think designer of the vehicle, designer of the product. But he was really the designer of everything, of the whole factory, of multiple factories. And he would go down to the factory and look around. And he saw patterns where work wasn't getting done. You would carry, hopefully you can see my face and see my hands while I'm doing this, because you would carry a part all the way across the factory to one station and run for an hour. You'd pick up the finished parts and you take them somewhere else to another station and then run that for an hour, and you take them all the way across. And there was a lot of square feet involved in this motion. Why don't you put all of the machines together so they come out of one and go directly into the next? This is not that brilliant. And yet, until you came to the factory floor and looked at it, if all you looked at was accounting reports, if all you looked at was summaries, if all you did was you went to meetings where you talked about the work, if you didn't see it, you would never notice that, and it wouldn't get improved. So the Japanese word that he used was muda, or waste, is a rough translation. And what I want to do is look at all those ideas and say, of the ones that make sense, what would that mean for software? And I think we've been doing it long enough, and we've had enough positive outcomes to say, this works. And it's a different way of looking at it. So he identified 7 types of waste: transport, inventory, motion, waiting, overproduction, overprocessing, and defects. Those are on your left-hand side of the screen. And on the right-hand side, how we talk about it in the book, Software Testing Strategies. And it's got a nice little abbreviation we use, which is now time. Oh, excuse me. So it's interesting, if you look at the left, you see defects are last. You know, we usually think defects first when it comes to quality, but there's all these other aspects of things that steal our time. So when we talk about defects, I'm not necessarily talking about it steals our time, but more like, well, I'm not necessarily talking about the bugs cause a bad experience for the user. I'm talking about it steals our time. I'll explain that. When you have a manufacturing shop floor, I have a friend, she's a reclaiming QA. So what that means is they got a shop floor, and they have when you make a part badly, you have waste, you have physical material, metal, that you throw in the garbage or you send to the recycler. So they'll say something like, we are sending we have 4 tons of waste per month. And you can get a calculator out and you can say, what's the price of aluminum? Okay, there's so many thousands of dollars per day that are just waste. Forget the time of the person to do the rework or to fix it or all of those things. This is just waste. So in a manufacturing shop, you can say, we're going to set a goal. We're going to cut that number in half. That's going to save us $100,000 a month and create all kinds of processes around it. In software, we usually don't have any ways of measuring the waste that defects cause. So if you find it before it goes out to the customer, you've still got to, let's see if we can get this right. You've got to figure out what exactly the problem is. You've got to maybe write that down. You've got to communicate that somehow to someone. If you're lucky and you're in an agile shop, they're just going to go fix it. But they might not be able to understand what you mean. Then you might have to have a silly argument about whether or not we should fix it. Then they agree that they should fix it, but they can't reproduce it. Then you help them reproduce it. Then they fix it. Then you wait for a build. Then you test it all over again. That's not necessary if we just got it right in the first place. And I'm not saying we should be zero. I've worked on a few projects with no user interface that are just database transformations where there are no defects. But when you have that pesky customer involved that can click wherever they want and do whatever they want to do, I'm probably gonna have some defects. But most companies that we work with can radically reduce the amount of defects that they see, getting to the point where a human being is doing testing. The next one I'm going to mention is overproduction. And that is making more than you need. In software, that would be making more than our minimal viable product, or more than what we need for just the next release. Sometimes it's called gold plating. Early in my career, I worked on a project where we just sliced the work up into little chunks and let the customer sort whatever they wanted. And by the time we got to about halfway through the project, they realized the stuff that was the second half of the project, they didn't need any at all. And in fact, they had better ideas. So basic Scrum Agile software development does this well. But I think most organizations I work with have an opportunity to improve. The next one I really think we have an opportunity to improve on is the waiting. That's like, as a consultant, I can't tell you how many companies I've worked with that they say, oh, we're a continuous delivery shop, Matt. We don't need any help with that. We're amazing. We're fantastic. Okay. And I go in, how does this, walk me through it, right? Let's talk about what you're working on right now. Well, what I'm going to do after the commit is done, after the push to version control, it's going to automatically kick off. No, it has to be code reviewed. So I think it automatically kicks off CI/CD. There might be some failures. There's a percentage failure rate of the CI/CD. It's too high. There's rework. But when it finally works, then we have to go through code review. How does code review work? Well, someone gets an email, and within the next 2 business days, they'll come and do their code review. About 50% of the time, it passes. The other half, we've got 2 more business days to get the code review done. Then what happens? Has to be merged. How does the merge work? Well, it sends an email. And within 2 business days, someone's going to come in and they're going to do the merge. Okay, right. Well, then what? Then we do another CI/CD run in a staging environment. Okay. How often does that work? Well, about 25% of the time. Usually there's rework. And okay, now what? Well, then there's final sign off or whatever we have to do to marshal all of the work together to send it in a batch for the next deploy. Okay, when's that going to be? 2 more days. So I'm talking to a company that is doing continuous delivery, but the time frame from push to version control to in production is 9 business days. That's like a week and a half. It's definitely going to straddle 2 weekends because of the way math works, right? There's an opportunity there. The problem with, so in the West, when it comes, what we typically do culturally is we say we have to be busy all the time. We have to be working. So what I'm going to do is while I'm waiting this 9, 10 days, 14 regular days, 10 business days for my code to get out, maybe your organization's better, but I got to find something else to do, right? So now we introduce multitasking, which I'm going to talk about later. Multitasking introduces overhead, which causes delays. But it's hidden. You don't notice it unless you do the math, unless you go to the real place. The Japanese word there is gemba. Unless you go to the real place and study it, you can't see it. It's just going to show up in your reports. So you've got all this waste that's just kind of hidden in the work itself. Transportation waste, moving from place to place. Maybe you don't have that if you're working remote right now. I did work with one company, and I want to stress this. I worked with one company where once a week at 2 o'clock, we would take a walk over to a room where we would do like some team building stuff and then a walk back. It was a large campus. It was maybe a block. And on the way, we would talk about what we were doing. And every team member found that valuable. In fact, the walk was more valuable than the meeting. So if the team finds it valuable, I wouldn't call it waste. This is not an opportunity for someone from above to sort of say, get at your desks, I'm going to get a stopwatch. But we can look at the things we're doing and say, where is the waste? The whole team agrees is slowing us down. How can we get rid of it? Which brings me to inventory. One company I worked with, it was like they were doing something like Scrum. This was a while back, something like Scrum. But it was we, the testers, would be testing Sprint 21 while the developers were working on Sprint 20, while the business analysts were working on Sprint 19, while the project managers were working on Sprint 18, and then you go the other way because operations was trying to get. I did the math backwards there. The operations people were trying to get the previous sprint on production while we're testing the next one and all the way back. And I said, there's too much inventory. Like if this were a physical warehouse, we would have shelves and we'd have a building to heat and we'd have a security guard, we'd have insurance, we have square feet, and we'd say, wow, this inventory is costing us just to keep it running. Our work in progress inventory is too high, but it's all invisible. We should put it on a wall. And we had a back wall. It was a big open space room. It was a big project. The wall was probably like a elementary school gymnasium size wall. We should just print it all out, put it on the wall. And my superior said to me, we can't do that. And I was waiting for some rule or some policy. And she said, it wouldn't fit, right? That's inventory. That's too much inventory. Motion. This is hands. Inventory, transportation is feet, motion is hands. So a lot of companies have gotten a lot better at this recently, but there are still companies that we go into version control, we right click download, we bring up the thing, we press F5, we get the executable, we FTP it over to the server, we run this. A lot of that is scripting up the test environments, the actual creation of the test. We use Kubernetes. It's amazing. It's fantastic. Okay, what does it take for me to get a test environment? Well, I run this script and I run that script and I go to this box and I copy this and then I set up the data and I do this and I do that. How long does it take? Hour and a half. How much is the testing time? 8 minutes. I'm exaggerating. Most companies are better than that, but I do see a lot of value opportunities in tightening these up. And excess processing would be too high quality. So, for instance, human beings can't really discern time past around a quarter of a second. So if you're optimizing your search results to come back faster than a quarter of a second or a page to load faster than that, there really isn't a lot of value to be pursued there. And that's the 7. So if we had all day, we would run an exercise that simulates software development. And then we'd stop, I'd explain these 7, and we'd run it again, trying to follow the rules that I'd set up. But you can do whatever you want within these 7 to make it tighter. And typically performance we roughly get a doubling of human performance when we do that. And it's a real simple exercise and we can measure it. I could describe it to you sometime, but that's twice as fast. What? From what I can, and it's harder now that we're remote, now that we're distributed. You talk to your boss on the phone, describe the work. Like I'm working on Jira ticket 1, 2, 3, 4, 5, and tomorrow I'm going to do Jira ticket 6, 7, 8, 9, 10. And if you get into any real depth, someone will say that's not what stand up is for. And we've lost this concept of really understanding the work across the organization. So the people who have the impressive titles don't have what they need to do the improvement. But I think we can drive the improvement. And retrospectives are one place that we can do that. So I've been talking for a long time. We got a lot to get going. Let's talk about bottlenecks for a minute, right? So testing. I don't know. I'm sure as long as I've been in the field, I've heard people say testing's a bottleneck. Why is testing always a bottleneck? Like, yeah, right. Exactly. We've got garbage in the bottle. We don't want it to come out. So we have this little lip at the end to make sure that only the good stuff comes out. Is one way to think about it, right? A filter, if you're in the ocean and you've got a filter on your water, so you drink the little straw and what comes up doesn't poison you, the filter's a bottleneck. That's a good thing. But there's also just math behind it. So Eli Goldratt wrote this book, The Goal, and he talks about constraints. So if you have a factory where you've got a bunch of different steps, right? Paint, dry, QA, cutting, and it's got completely equal throughput, but there's any variability in it. And the way he simulates that is with matches and dice. So you roll a die and you move that number of matches down, and then the next person rolls a die, and you do a few rounds of this. Like statistically, sooner or later, someone's going to roll high numbers and get a bunch, and the person behind them is going to roll low numbers, and that's going to create a bottleneck. So even if your throughput is completely averaged out all the same throughout all the stations, if there's any variability in there, bottlenecks will emerge naturally. That is math. So what can we do about that? There's a few things we can do. What you actually should do when you have a bottleneck in constraint theory is you get stuff out of its way so it can keep working on the main thing most of the time, and you add resources to it, right? But there are other things we can do to decouple so the testing can happen. It doesn't cause delay. But what I really recommend that I'm excited about right now is getting so good at what we do in testing land that the value is unquestionable. That if you say we got to slow test, we got to get rid of testing, it's a problem. Everyone else in the room stands up and says, no, that's foolish. You don't understand what they do. I don't think this talk gets into that a lot, but through one way to do it is through coverage models. Then we can create the coverage models and we can pass those over to our stakeholders and they can decide how much coverage they want on what. And then have a lot higher confidence that they're investing in the right things. I do think testing historically hasn't done a great job of explaining its value and in communicating where the risks are and letting the customers feel in charge or have some ownership of where we invest in mitigating those risks. But we're still talking about flow. So the point of this sort of most of this talk is just about how to improve the velocity of knowledge work with a grounding in testing. So and one of the things we talked about was this idea of different workstations and work piling up because of bottlenecks. Another problem that I frequently have is that, as you see in the illustration, work comes in one inbox, and then you pull, in this example, you would pull out the bottom and then put it into the next step. Well, you can imagine that all these boxes are full, and there's 4 or 5 or 6 of them, whether they're analysis and development and testing and whatever they are. So that if it takes you a day to get through each step, to work through the whole system, it takes you 5 or 6 days. And we usually, so this happens when we don't limit work in progress. So if there's unlimited work in progress, people are multitasking. They're multitasking because they're waiting. Waiting is like the king of the wastes because it causes all of the other ones. And what that'll do is you'll always be efficient. You'll always be working, but the amount of stuff that comes out the other end is going to be very small. And I'm going to give a couple more examples of that. So the solution for this is to limit work in progress. And so I listed a bunch of these sort of, for lack of a better term, sins at the top of the hour, right? The 7 wastes. What do they actually do? Is there some way to measure them? Is there some way we can say, hey, this is the impact of these problems? And if you changed our way of working, then the impact, things would improve, and we could measure and show it to you. And there's 2 ways I want to talk about lead time and cycle time. Lead time being from when we've defined the work to when it's actually in production. And I worked with a company, it was a while back, but they had 18 months of work defined up front, 18 months of requirement documents. And they were very, very proud of this. Like 18 months of backlog for you. The bottleneck is engineering because analysis has done a fantastic job with getting this stuff all defined up front. Well, that was terrible because if an executive had a new request that came in that would take us a week, when can I have it? 18 months and 1 week from now. It's inventory waste, right? Plus, we're not going to do this stuff at the bottom of that stack. The low priority stuff at the bottom of that stack, we're not going to get to it. By the time we get to it, we'll have new requirements that are better. Well, someone will have a better idea. If we did get to it, it's probably not going to be current. We're not going to know what it means. We're going to have to go get the analysts that wrote it. They're not going to remember because this is 18 months ago. And they probably quit. 18 months is a long time. If they're probably not in the division anymore, they might be in transfer. They're not going to remember. We're going to have to do it over again. So everything past 9 months really was waste. This thing we're so proud of, we've created all these JIRA tickets. Look at this. Not only was it also created sort of a needle in a haystack problem where there's so much inventory, we can't find what it is we're missing. This is a recurring theme on police shows in television where they lose the evidence in the evidence log. We don't want this problem. Well, one way to understand that, to look at it, is to say, from when the ticket is created to when it's live, how long does that take, and how can we shrink that, right? Another way to reframe the conversation is to say, if it's your number 1 priority, if it's the company's number 1 priority, then from the time that you give it to us fully defined to when we actually implement it is a much smaller number, a week, 2 weeks, whatever that is. So we focus on that. Let's deal with the top of the stack. Let's deal with the roadmap. What's next? What's the next thing on the roadmap? And because most roadmaps have a great deal of detail about how the world is going to be like in 24 months, 4 years. Like from an engineering perspective, we can get really, really good at what's the roadmap say we're going to do next week. I'm covering a lot of ground, but he gave me 45 minutes. So lead time, and then there's cycle time, which is the bottom. If you look at the picture, it's the bottom part. Cycle time is from when we start work to when the system, when it's live. And you can measure the cycle time of anything. You can measure the cycle time of just a small piece of it, like just what's the development cycle to get it to consider live in version control, or a wider piece of it. What I'm particularly interested in with most companies I work with today is from the commit to version control to on production. How long is that? How can we make it shorter? Because not only does that radically reduce our time to respond, if there's a problem, if there's an incident, if we radically shrink that, what we're gonna do is we're going to shrink the fix, which is going to shrink the net problem time on production. But also it'll get rid of waiting. If we can get that number down to this afternoon, then a lot of the waiting and multitasking goes away, and waiting and multitasking is killer. And I think I talk about that next. Yeah, this is an old slide from Joel Spolsky. But we're just using the math that we just did. Sequential processing is I'm working on the same thing all the time. Multitasking is I'm switching between a couple of things. Now, the Agile movement's been pretty good about reducing the amount of multitasking. Most of us don't have a list of 9 different projects we're working on. But we still have, I pass that off to the next person. I ask a question from the DBAs. I'm waiting for clarification on my requirements. So I have to be busy, so I'm going to go work on something else. So this is just with 2. It's more fun to do with a much larger number. But just with the 2, just looking at it in terms of lead time, right? The first one, you do the math. It deploys on, the first deploy is on day 11, the second's on day 21, 21 plus 11, 32. Average lead time is 16. Second one, it deploys on day 20 and 21, 41. And the average lead time is 20. So 16 versus 20. So 20% improvement just by not multitasking. When you get to 3, 4, 5, it gets ridiculous. If we were doing a class, what we do here is we'd have 3 different groups, and they would do 1, 2, 3, 4, 5, 6, 7 in a circle, A, B, C, D, E, F, G in a circle, and then Roman numerals, I, V, I in a circle. And we'd see what numbers they get to. And then we'd try to have them do it together, which would be like 1A, I, 2B, I, 3C, I. And the performance falls through the floor, right? Now, most of us understand this. You may have heard this before. This is not new. It's not new insight. But my point is, when we have a slow CI/CD pipeline, we have a slow deployment process, all this wonderful work we did in Scrum to prevent the multitasking is going to come back because we're sitting around waiting for our code to be merged. And that's our next opportunity for performance improvement. And that'll get us looking at the test cycle, because that's where the test cycle typically lives, both testing a feature and also testing the system before deploy for regression risk. If you want another metric to use, I like touch time. So if I had a stopwatch for every time something was actually actively happening on the project, on the change, and I ran it. And a second stopwatch just ran all the time. And I would include running in the CI/CD pipeline as part of that something actually happening. And we finish the story, and we take the amount of actual time divided by total elapsed time, and we get a percentage. Just business hours, I'm not counting at night. Typical, reasonably functioning Scrum team in North America, 30%. If we go back to when the story was defined to the point that it might be actionable to an engineering team, that number could be like 3%, 4%, 5%. If we just looked at from version control to in production, it's typically 3, 4, 5%. It's doing nothing the majority of the time. So when someone says, gee, software testing's taking a long time, you say, well, you know, I did the math on our last story, and the touch time for that thing was like 20%. If we could double it, which is easy, like going from 20% to 40% is not hard. Going from 80 to 90 is hard. If we could double our touch time, we could have it to you. We could have changes to you twice as fast from when they start they start working on them. But that's also going to benefit everything else is going to go faster too, because we're going to do less contest switches. Do you want that? Here's how to get that. Now we're solving problems. I like to be a problem solver. If the organization says no, that's fine. We can't do it. This team doesn't let us. It's this and this. Give it think. You got to think outside the box, but not that far outside. It's fine. But then next time the question comes up again, you say, yeah, touch time is still 20%. Can we do something about it now? And I found that the third time you mention it, sometimes people say yes. Or when there's a reorg or a change in management, all of a sudden people are open to these ideas. I mentioned coverage earlier. Don't really have time to go into a lot of it today, but if we can model and visualize, these are all the pieces of the app and here's how well they're tested. Where do you want us to invest the scarce resources we have in testing? Very different conversation. As a manager, I've been like, when I don't know what's going on, scared isn't the right word. I think out of control is the right word. When people feel out of control and they have authority, they make very poor decisions. So if we can provide, hey, here's a model of our software. Here's where we think the risks are. Here's the risks that are not covered. Here is the risks that are covered. You can move anything you want, anywhere you want. Like you have 100 points to spend. Move them around. It's on a Google spreadsheet. We can adjust and change the way we invest our time. The organization can make mature decisions about how to invest in risk. So then, really like, is why didn't testing find this bug? Well, actually, that was on our risk list, but it was below the cut line. So here are the things we did find that were above the cut. Oh yeah, those were a lot worse. Okay. So it seems like we made the right decisions about how to invest our time. I've had that conversation before and had people say, you need more time to test, or we need to add more people spending more of their time on testing activities to the team. If you say so, boss, sure. Okay, that's fine. Very different conversation than why didn't you find those bugs. Another strategy, which I alluded to, is the census of risk, which is we assign a priority to the things. Maybe they're not worth writing a tool to automate. Maybe we just want to run them once. We're just kind of worried about them. We have a spreadsheet somewhere. We publish it. It's got priorities. When we actually do the testing, we move them off the spreadsheet, move them to a different tab. And then that's where our cut line comes in, because we can predict how much time we're going to have to investigate in these other tasks. So if we need more, you need to test better. Okay, well, do we give us more time, give us more resources, move stuff around? What do you want us to do? We've actually empowered management with tools to actually answer those questions. And we've eliminated the whole do your job better, work overtime, or else kind of ridiculousness, which we sometimes hear. And that's most of it. I got 4 minutes left. I have a putting it all together slide that takes about a minute and a half. But do we have any questions before I get there? I know I've been talking fast, but you said 45 minutes.
Nothing in the chat so far.
All right, I'll say it once. The book at the bottom right is Software Testing Strategies. I wrote it with Michael Larson. It represents the best I have for what I think is a reasonably long career. We're pretty proud of it. And if you really want a lot more detail on these topics that I just breezed through, the book's on Amazon. If you like it, please give it a 5-star review. If you don't, please don't give it a review. Just talk to me. I'll find you time on the phone, and you can yell at me all you want.
Looks like we do have one question in the chat now, Matt. Could you explain the concept of touch time again?
Okay, yeah, I went through that pretty quick. So let's have me. So you can't see it very well, but that's actually an actual real Kanban board from a real customer that I worked with, and they used a there was a tool that we used behind the scenes, um, but that was just for our visualization, so we could really see it. And you have the backlog, test case creation, dev, code review, ready for QA, QA, ready for deploy, deploy, and done. Those are the steps. So imagine the story comes in to the sprint and we immediately have a test case creation meeting. And as soon as that's over, it immediately goes into development. Is that true? No, because we'd have to schedule the test case creation meeting. So you could start this one stopwatch and it's running, the other one isn't. You pull it into test case creation, you run, because we're actively doing work. We're going to track active work. And then, and after test case creation, I don't know, there's some team meeting or something. So you unclock the active work, but the other one's still running. The other one is all the calendar time from we start to finish. And the first one is just the time that someone is actually working on it. We come back from the team meeting, start the active work clock, and we're tracking the time. It takes them an hour to program, and then we're done because we'd have to schedule the code review. We have to go find, and then have to wait for them to finish whatever task they were on. So the developers might try to pull another story in, and then we'd have a code review. And then when the code review was done, we would wait for a tester to be available to pull that story in on the tester clock, and we start the clock again. So one clock for active work, the other for calendar time between we pulled it into the team and it's in production. So the active work on that thing to get it done, and this is a pretty high functioning team. I'm trying to think of some realistic numbers for you. The active work might be 2.5 hours for a small story. The calendar time might have been 5. So you divide 2.5 by 5, you got a touch time of around 45%. I think that's actually pretty good. Um, I'll ask the board. I just explained that again through a story. Did that explanation make sense?
I think so. We'll see if anything else comes back in the chat to expand on it at all. We did get, yep, looks like that explanation helps. So thank you for that, Matt.
Yeah,
We
yeah.
get another question as well. So really recognize the value and challenge of communicating the value of what we're actually doing. So can you talk more about that? I think specifically around like how to communicate that value.
Yeah. So I should have a coverage, right? So the top right is actually a coverage map for a real client. Um, I don't think it's even super grayed out. Yeah, it was a Silicon Valley startup and we got permission to share it. So they said we need some testing resources. We don't know what we're doing. Like we don't have a formal program for this, and it's a startup, so it's not a big app now, but it's gonna get bigger. I said, great, give us a reasonably small pile of money. We'll put a couple of people on it, and we'll just test the thing for an hour. And we document the build out of our perception of the features. And then we gave it back to them and said, not only here's your bug report, but here's all the stuff we did, and here's the stuff we found. Was our understanding of the features correct? Could you review it? So we've had customers that take this kind of a mind map and they use it as an architectural diagram. They map out to different teams. They map out to different teams' responsibilities. We did this with one customer, and it was just major features in a mind map like tool. And then they said, who's responsible to maintain? It was a big project. That was I'm trying to think. That was like 13 teams on 3 or 4 continents. Reasonably big for us. And they had features that no one was responsible for maintaining at all anymore because it was built by a contract team where there'd been a reorg. It's like, so who's testing that? And they were using Safe and they were doing uh, product increments, and they had a 2-week testing sprint at the end. And like, who's testing that during those 2 weeks? No one at all. So there was essentially no regression activities happening for any of that. We found that out through our diagram that we did through a test improvement project. It's, okay, you've got to assign someone as responsible for all these things before we can take over and make your testing as awesome as it could be. Um, so you create the spider diagram, and then we will come up with a number, 1 to 10, because we have our own internal rubrics. One is 0 to 10. 0, I didn't test it at all. 1, I breathed on it, didn't fall over. And usually never get to 10, which would be something close to complete testing. The book has a whole chapter on complete testing. You're not going to do complete testing. But 9 is like, we came up with all of our testing ideas. We looked at everything we've done in the past. Every single person in our small group came up with ideas. We ran them all. We shared them with each other. That created more ideas. Then we ran all those. And then we looked at the result of the running, and that gave us more ideas. We ran those. Like 9 is relatively high level of testing, and it goes down. So you can say on a regular basis, this is a level of testing this occurs. And you factor in whatever tooling we're running, whatever Cypress, Selenium, whatever it is, Playwright. And I think our Playwright doesn't do much more than breathe on it, but everything is automatically at 2 because we have these things. A couple things happen with that. One, you find the empty pockets and no one's testing at all. Another one is you can say, this is how much we invest in testing. What would you like to change? What's important? You can run through an RC analysis, which is Karen Johnson came up with the acronym. It's recent, changed, chronic. There's a bunch of them. But you can say these are the things we think we would put effort on if you gave us the time. And then we have the spreadsheet of these are the things we want to put effort on if you give us the time. This is how much time you're giving us. This is how much time you're going to get. So you've created visibility into what testing is covering. So if you're an executive, to some extent, that means these are the things that I can just go to sleep at night and not worry about. And we can talk about the ethics of that too, but like it gives them a sense of control. Now you take that, you make it a URL, and you publish it. You send it to everyone. Hey, look at our testing. Look at how well we are covering things. If you want it to change, tell us. And then the question is, okay, you want more testing there? What do we take away from to get more testing there? Oh, you want everything more. Okay, do we slow down? Do we add resources? Do we change our priorities? Do we do less of other projects? How do we do it? That's an engineering conversation about trade-offs. And all of a sudden, you're having a strategic conversation about risk, not a silly conversation about do it faster, why is it buggy, right? If anybody is tired of do it faster, why is it buggy, this is what I'm trying to talk about.
Thanks, Matt.
Right.
Got another one in the chat as well. Could you elaborate on some tips or advice on how to avoid the multitasking inefficiencies as a QA developer? So kind of the what should be done while code is in review that isn't just starting another story.
Well, the first thing I would do is I'd track the numbers, right? I would say, hey, did you know that our cycle time is this, our lead time is this, and our touch time is this? And then ask the question, how do we reduce that? So firefighters, I'm sure people are familiar with this. In a big city, firefighters will be paid full time to sit around and do nothing, to do tasks that aren't that important, while they're waiting for something important to happen. So you can play cards or you can work out or whatever it is, but you need to have your suit on within 2 minutes to go down the pole. Because multitasking, like doing something constructive that really engages you is actually a problem. So then the question is, how do we, now that we know these numbers and they're terrible, so one is like, I don't know that 100% efficiency is that important. You say, what can I do that can be dropped easily? To go back to the firefighter analogy, what do I do that can be dropped easily so that when something comes up, I can respond to it, right? And there are ways to do that. Companies I've worked with have had they call it the Batman role, which I think is based on the superhero, where like dropping everything to do code review this week to try to get our cycle time down. To get there, I would measure it and publish it. Why is everything taking so long? Well, here are numbers. They're lean numbers. There's a book on it. Like it's a standard. If you don't like me, the Dora metrics are pretty good too. They're a little broader than my stuff, but like we need to change our processes to be more efficient. And so I think you need to change the process in terms of like, but Matt, I'm just a tester. What can I do within whatever group of people you have doing testing? You can have someone who's more dedicated to responding quickly to these things as they pop up to try to get those numbers down. I don't have a fully satisfactory answer. You're going to have to change the organization, but there's a couple small things you can do.
Anybody else have any questions for Matt? Oh, and you did get a reply. Great answer. Thank
Oh, hey, this slide is the answer to the question. So
you.
analyze your cycle time and touch time to production. If it's high, propose to fix it. If you can't, then at least you can explain why there are delays in the system. And what do we do to fix it? Go back to the thing I told you to do yesterday. And for estimates, like I'm more interested in cycle time than I am in like forget it. The backlog stuff is not like if you make it my number one priority, this is how long it's going to take us. I like the spider diagram of test ideas and publishing it because then you can make trade-offs. Like we want this faster. Okay, well, let's just color all of these leaves of the spider diagram gray and this is just a production break fix or whatever we're calling it, so we can just test around here and we can get it out faster. Is that cool? Sometimes the answer is yes. I mentioned the risk spreadsheet. I don't have a slide for this, but I did mention taking these ideas and publishing them. What is our dashboard? If you were an executive and you wanted to come in and turn knobs and change outcomes, like a little more of this, a little less of that, go faster, go slower. What is your dashboard that you present that to your executives? Where can they go and find out what your cycle time is and your touch time, your lead time? Where do they go? And the answer is probably most companies in the West. Oh, I don't know. So when you give answers like, I don't know, then people feel out of control. When they feel out of control, they make decisions we're not excited about. And I'm tired of being a victim. So in 45 minutes, I tried to offer you some alternatives that I think are pretty good. So thanks.
Awesome. Thank you so much for coming in and giving this today, Matt. And Annette was just asking, the discount code is to February 28th of what year?
Oh my gosh, this is an old slide. So you can try it. Why don't you test it? So I have asked them to extend it. It's supposed to be extended through April. So the best way to get the book probably is to go to pack.com. If you want to save money, go to pack.com and get the digital edition. That should be almost 50% off of the Amazon price. You can try the discount code, which I've asked them to extend it through the end of April, but I have not heard back that it's been extended. So
somebody just said it worked, and I missed a question in the chat, which was, is there anything new that you would have added to the book if you wrote it now?
yeah, so just that it's kind of preachy and sounds like we have all the answers and like we got it all figured out. We talk about, particularly we talk about integrity, we talk about ethics and philosophy. I'm really happy with that chapter for the most part. But there one of my mentors, Dave Limbaugh, once told me something like there's an old prayer which is, Lord, help me to forgive those who sin differently than I do. Right. So maybe I personally don't have a problem with integrity right now in my life, but I get a lot wrong. I'm not perfect. And if the book sounds that way, that was a mistake. I think I've developed enough ideas over the years with Michael that they're worth sharing. That's the big thing that I kind of regret. I think there's a bunch of kind of little operational stuff. Um, But and I want to get more I want to get more case studies in it. So if we do a second edition, I want to have more. Here's how we applied the ideas. Yeah, we read the book and then we did it. And you know what, Matt? Da, 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 da. I think that'd be good. Thanks for asking.
Well, thank you again. And thanks everybody for joining us today for this month's quality talk. Like I mentioned earlier, watch your emails and hopefully you can join us at either our April quality talk, which again will be in person, or we should be back online in May.
Okay.
Thanks everyone.
Thank you.
Thanks.